Welcome to online learning program of MSBTE, Learning at Your Doorstep. I am Sangeeta Bhoyer, lecturer at VES Polytechnic, Chembur, Mumbai. Today, we are going to discuss Boolean variable manipulation instructions and program branching instructions from Unit 2, Instruction Set and Programming. So, today's learning outcome is to describe the function of various Boolean manipulation and program branching instructions with suitable examples. Under this, we will see how operation can be done on single bit operand and how switching of execution of instruction in program can be done. In the previous lectures, we have already discussed that instruction set of 8051 microcontroller is having 5 types of instruction: data transfer, arithmetic, logical, Boolean variable, and program branching instructions. We have already discussed data transfer, arithmetic, and logical instructions in earlier lectures. Today, we will discuss Boolean variable and program branching instructions. Clear, setbit, CPL, ANL, ORL, move, JC, JNC, JB, JNB, JVC. All these instructions come under the category of Boolean variable manipulation instructions. ACALL, LCALL, RET, RETI, AJump, LJump, SJump, Jump, JZ, JNZ, CJNE, DJNZ, and NOP instruction comes under the category of program branching instructions. Boolean variable manipulation instruction. These instructions are used for one bit operand, that is single bit operation can be possible. CLRC. This instruction clears the content of carry flag. If carry flag contains 1, then after execution, carry flag will reset to 0. CLR bit. This instruction clears direct bit given in the instruction. Example, clear P1.2. Direct bit P1.2 will reset to 0 after execution of this instruction. Set C. This instruction set the carry flag to 1. Set bit. This instruction set direct bit given in the instruction. Set P1.2. Direct bit P1.2 will reset to 1. CPLC. This instruction complements the content of carry flag. It changes 0 to 1 and 1 to 0. CPL bit. This instruction complements direct bit given in the instruction. ANL C, bit. This instruction and direct bit given in the instruction to carry and store the result in carry flag. For example, ANL C, P0.1. If carry flag contains 1 and P0.1 is 0, then after AND operation result is 0 that will be stored in carry flag. ANL C, /bit. This instruction AND complement of direct bit given in the instruction to carry and store the result in carry flag. Example, ANL C, /P0.1. If carry flag contains 1 and P0.1 is 0, then AND operation is performed on complement of P0.1, that is 1, and carry. Result of AND is 1 that will be stored in carry flag. ORL C, bit. This instruction or direct bit given in the instruction to carry and store the result in carry flag. ORL C, /bit. This instruction or complement of direct bit given in the instruction to carry. Move C, bit. This instruction moves direct bit given in the instruction to carry. Move bit, C. This instruction move carry to direct bit given in the instruction. JCREL. If the carry flag is set, it transfers the control to the location specified by the relative address. Otherwise, execute the next instruction. Flags are not affected in this instruction. JNCREL. If the carry flag is not set, then it transfers the control to the location specified by the relative address. Otherwise, execute the next instruction. JB bit, rel. If the direct bit is set, it transfers the control to the location specified by the relative address. Otherwise, execute the next instruction. JNB bit, rel. If the direct bit is not set, it transfers the control to the location specified by the relative address. Otherwise, execute the next instruction. JBC bit, rel. This instruction jump if direct bit is set and clear the bit. If the direct bit is set, it transfers the control to the location specified by the relative address and clear that bit. Now, before we proceed further, please attempt MCQs from set 1, which is given you as assessment sheet. Proceeding further, we have program branching instructions. A microcontroller sequentially executes instructions, but in some cases, transferring this control to another block of code becomes essential. The branching instructions are responsible for performing this operation. Tasks like looping, calling delays, and unconditional execution of code can be performed using these branching instructions. 8051 microcontroller having 17 different such instructions. These instructions are categorized as call, return, and jump. Call instructions. A call address 11 absolute subroutine call. It unconditionally calls a subroutine located at the indicated address within 2K program memory block. It increments program counter by 2 and generates the address of the next instruction and save this address in a stack. The PC is then loaded with 11-bit address given in the instruction. Lcall address 16. Long subroutine call. It conditionally calls a subroutine located at the indicated address within 64K program memory block. This is 3-byte instruction, increments program counter by 3 and generates the address of the next instruction and save this address in a stack. The PC is then loaded with 16-bit address given in instruction. Return instructions. RET. Return from subroutine. RET instruction is used to return from subroutine previously called by lcall or acall. RETI. Return from interrupts. RETI is used to return from interrupt service routine. RETI first enable interrupts of equal and lower priorities to the interrupt that is terminating. Program execution continues at the address that is calculated by popping the topmost 2 bytes of the stack. The most significant byte is popped off the stack first, followed by the least significant byte. NOP. No operation. This is no operation instruction causes no operation to take place for one machine cycle. NOP is generally used only for timing purposes. Jump instructions. A jump address 11 absolute jump. It causes an unconditional branch to the indicated address by loading the 11-bit address to program counter. The destination must be located within 2K program memory block. L jump address 16 long jump. It causes an unconditional branch to the indicated address by loading the 16-bit address to program counter. The destination must be located within 64K program memory block. SJMP REL short jump. SJMP jumps unconditionally to the address specified relative address. Relative address must be within -128 to +127 bytes of the instruction that follows the sjump instruction. JMP @ A plus DPTR. Jump indirect relative to DPTR. The jump instruction transfers execution to the address generated by adding the 8-bit value in the accumulator to the 16-bit value in DPTR register. Neither accumulator nor DPTR is altered. JZ REL, jump if accumulator is 0. The JZ instruction transfers control to the specified address if the value in the accumulator is 0. Otherwise, next instruction is executed. JNZ REL, jump if accumulator is not equal to 0. The JNZ instruction transfers control to the specified address if the value in the accumulator is not 0. If the accumulator has value of 0, the next instruction is executed. Continuing jump instructions. CJNE A, direct, REL. This instruction compares the content of accumulator with the content of direct address given in the instruction. If contents are not equal, then jump to the relative address. CJNE A, hash data, REL. This instruction compares the content of accumulator with immediate data given in the instruction. If contents are not equal, then jump to the relative address. CJNE RN, hash data, relative. This instruction compares the content of register RN with immediate data given in the instruction. If contents are not equal, then jump to the relative address. CJNE @RI, direct, REL. This instruction compares the content of internal memory location pointed by RI with content of memory location given in the instruction. If contents are not equal, then jump to the relative address computed by adding the sign displacement to the content of program counter. DJNZ RN, REL. This instruction decrements the content of register RN given in the instruction by 1. If contents are not equal to 0, then jump to the relative address. DJNZ direct, REL. This instruction decrements the content of direct memory address given in the instruction by 1. If contents are not equal to 0, then jump to relative address. In all these instructions, relative address is computed by adding the sign displacement to the content of program counter. Now, please take MCQs from set 2 which are given in your assessment sheet. Thus, today we have discussed various Boolean variable manipulation instructions such as clear, setBit, complement, AND, OR, move, JC, JNC, JB, JNB, JBC. All these operations can be done on 1-bit operand. We have already discussed program branching instructions. In that, we have discussed call instructions, return instructions, jump instructions, JZ and JNZ instruction, then CJNE, that is compare and jump if not equals to. Then we have discussed DJNZ instructions and NOP instruction. Thank you.